Here in this section we have composite and inverse functions. The composition of the function f with g is denoted by f of g and is defined by f of g of x equal to f of gx. So the domain of the composite function f of g is a set of all x such that x is in the domain of g and g of x is the domain of f. So here, based on what we have for f of gx, this x is input for what we have for g of x. So that means x is domain of g. And what we have here for this part, g of x is input for this function f. That means g of x is domain of f. So here on this part, we have exactly what I explained here. So step 1, input is x into g, and step 2, input is g of x into f. So x is domain of g and g of x is domain of f. Note that the output from inner function becomes the input for the outer function. Exemplifying each of the following, we have these two functions f and g. F of x is equal to 5x plus 2 and g of x is x minus 2. Part A, find f of gx. So this means we have to find f of gx is x minus 2. So instead of gx, use what we have here on this part. And then here we have f, so we have to use this function, and instead of input, in this case our input is x, but we have to use x minus 2. So wherever we have x, we have to use x minus 2. So starting from here, we have 5 times, instead of x, now we have x minus 2, then we have plus 2. Use distributive property, so it's 5 times x, 5 times negative 2, plus 2, combine like terms, we have 5x minus 8. So this is our final answer for this part. Part B, g of fx. Now inner function is f. Instead, we have to use 5x plus 2. Then our outer function is g. So here instead of x, we have to use 5x plus 2. Starting from that part, we have x. So instead, we have 5x plus 2 and then minus 2. Combine like terms. So the answer is 5x. Part C, f of g3. So inner function is g. And here g of x is x minus 2. So finding g3, that is 3 minus 2, so it's equal to 1. So that means here we have f of 3 minus 2, so that is f of 1. Now use this function f of x, and instead of x we have 1. So this is 5 times 1 plus 2. And our answer is 7. Now here on this part, f of x is equal to negative x squared plus 3x minus 4, and g of x is equal to 2 minus x. We have to find f of gx. So inner function is g, and instead of gx, we have to use 2 minus x. Now we have to use this function f of x, and instead of x, we have to use 2 minus x. So starting from this point, negative x squared, so instead of x we have 2 minus x, plus 3 times 2 minus x, minus 4. So here 2 minus x times 2 minus x is equal to 4 minus 4x plus x squared. And then here 3 times 2, 3 times negative x. So here we have positive 6, negative 3x, then subtract 4. Then we have to multiply this negative sign. So we have negative 4 plus 4x minus x squared plus 6 minus 3x minus 4. Combine like terms. Final answer is negative x squared plus x minus 2. Part B, find g of f(x). The inner function is f of x. We're using negative x squared plus 3x minus 4. Now other function is g. So here instead of x we have to use negative x squared plus 3x minus 4. So we have 2 minus negative x squared plus 3x minus 4. Then negative times negative x squared. So this is positive x squared, negative times positive 3x is negative 3x, negative times negative 4 is positive 4. Combine like terms. So our answer is x squared minus 3x plus 6. So this is our final answer for this part. Part C, f of g2. We can use what we had in part A, because here we have f of g, x, but instead of x we have to use 2. So using what we have here, instead of x, use 2. So it's negative 2 squared plus 2 minus 2. So our answer is negative 4. Decomposition of functions. Express the given function h as a composition of two functions f and g, so that hx equal to f of gx, and one of the functions is 3x minus 1. So here h of x is equal to 3x minus 1 power is 4, because of having what we have here, f of gx. Gx is inner function, and this part is inner, so that means g of x is equal to 3x minus 1. So g of x equal to 3x minus 1, and what we have for outer function, that is f of x, and here power is 4. So f of x is equal to x to the 4th power, and that is because f of gx is equal to, so instead of gx, here we have 3x minus 1, and using this outer function, instead of x, we use 3x minus 1, power is 4. So this is what exactly we have here on this part. So if you were not sure about your answer, try this part and see if your final answer is the same as what was given. Part 2, h of x is equal to 1 divided by 3x minus 1. So again, we have f of gx, and gx is inner function. So for inner function, we have 3x minus 1. So let f of x equal to, here we have 1 divided by So 1 divided by, again, based on what I have here, I'm using same variable, so it's 1 over x, and g of x is 3x minus 1, and that is because f of gx is equal to f of 3x minus 1, and then using this function f instead of x, we have to use 3x minus 1, so that is 1 over 3x minus 1, and this is exactly the same as what we have here on this part. So our answer, this one is correct. Inverse functions. Definition of the inverse of a function. Example, find f of gx and g of fx if gx equal to 1 over 2x minus 2 and g of x is equal to 2x plus 4. So finding f of gx and g of fx. Here for f of gx, gx is inner function, so instead of gx, here we have to use 2x plus 4. So we have to find f of 2x plus 4. And then this is our outer function. So use f of x, and instead of x, we have to use 2x plus 4. So that is equal to 1 over 2 times, instead of x, 2x plus 4, and then subtract 2. Distributive property, 1 over 2 times 2x, that is x, 1 over 2 times positive 4, x positive 2, and then subtract 2. So the answer for this part is equal to x. And then what we have for g of fx, now inner function is f of x, and f of x is 1 over 2 times x minus 2. And then here outer function is g, so use gx. Instead of x, we have to use 1 over 2 times x minus 2. So this is equal to, starting from this part, 2 times 1 over 2 times x minus 2, and then add 4. Use distributive property, 2 times 1 over 2x, that is x, 2 times negative 2 is negative 4, and then add 4. Combine like terms. Here again we have x, so for f of gx and for g of fx, we have same result, and that is x. What that means here for inverse functions, when we have these two functions f and g, and if we have f of gx equal to x, for every x in the domain of g, and when g of fx equal to x, the same result for every x in the domain of f, the function g is the inverse of function f and is denoted by inverse function. So this is inverse function, it is not -1. So read f inverse. Thus f of inverse function is equal to x, and inverse function of f of x, or f inverse of f of x, that is equal to x. The domain of f is equal to range of inverse f, or f inverse. So the domain of f is equal to range of f inverse, and vice versa. Find f of gx and g of fx and determine whether the pair of functions are inverse. So f of x is equal to 4x minus 7, and g of x is equal to x plus 7 divided by 4. So finding f of gx, gx is x plus 7 divided by 4. Now our function is f, so this is equal to, instead of x, we have to use x plus 7 divided by 4. So 4 times x plus 7 divided by 4, and then subtract 7. So here we have x plus 7 minus 7. This is equal to x. And now what we have for g of fx, so fx is 4x minus 7 Now using g instead of x, we have to use 4x minus 7. So 4x minus 7 add 7 divided by 4. This is 4x divided by 4, and that is equal to x. So here we have same result, and that is x. And our question was whether the pair of functions are inverses. Because of having same result x, that means our functions are inverses. So f is inverse of g and g is inverse of f. When we have ordered pairs, so in this case x comma y, then inverse of this ordered pair is y comma x. We switch order. So instead of xy, we have yx for inverse. Now here on this part is asking if this set is a function. Yes, this is function, and that is because domain does not repeat. For every input, we have exactly one output. So when for each input we have exactly one input, that means that domain does not repeat, and we have function. What is its inverse? So here we have to switch order. We have 1 comma 2. For inverse we have 2 comma 1. Here we have 4 comma 3. Here we have 8 comma negative 2. Close set. So what we did, we interchange ordered pairs. Note the procedure for finding a function's inverse uses a switch and solve strategy. Switch x and y and then solve for y. Example, find the inverse of the following functions. F of x is equal to 2x plus 7. Step 1, let f of x equal to y. So y is equal to what was given here on this part, 2x plus 7. Step 2, interchange x and y. So instead of y, we have x. Instead of x, we have y. Step 3, solve for y. So what we had here, x was equal to 2y plus 7, use that one. And then isolate y. So subtract 7 from both sides. We're going to have x minus 7 equal to 2y. So solving for y, we have to divide by 2 both sides. So y is equal to x minus 7 divided by 2. Then step 4, replace y with inverse function. So f inverse is equal to x minus 7 divided by 2, and this is our final answer. Now here on the spot we have f of x equal to 3 over x minus 1. So step 1, let y equal to f of x. So y is 3 over x minus 1. Step 2, interchange x and y. So instead of y we have x, and instead of x we have y. So x is equal to 3 over y minus 1. Step 3, solve for y. So here LCD is y, and I multiply both sides by y. So xy is equal to 3 minus y. And then add y to both sides. We have xy plus y equal to 3. And then here, factor of y. So we have y times x plus 1 equal to 3. Solving for y, y is equal to 3 divided by x plus 1. And then step 4, replace y with inverse function. So here, f inverse is equal to 3 over x plus 1. And that is what we have for inverse. The horizontal line test. Graphically, we can tell if a function has an inverse that is also a function using the horizontal line test. If every horizontal line intersects the graph in at most one point, then an inverse function exists. Determine which of the following graphs represent a function that has an inverse function. Here in part A, we have this horizontal line and we have these 2 points. So intersect in more than 1 point. That means our answer for this part is no. So inverse is not a function. But here for this part, intersect in at most 1 point. So the answer for this one is yes. Inverse is a function. That is same for this part. At most we have 1 point. So using horizontal line, this horizontal line intersect our graph in at most 1 point. So the answer is yes. Inverse is a function. We call a function that passes both vertical and horizontal line test a one-to-one function. For example, what we had for part B, if we draw a vertical line, this vertical line intersects our graph in only 1 point. So that means this is a function. And because of having inverse function, this is one-to-one, and that is same for this one, drawing vertical line and intersect in only 1 point, so at most 1 point. And because of passing both vertical and horizontal line test, this is one-to-one. But what we had for part A, using horizontal line test, inverse is not function. Even if we have this vertical line test, so here using vertical line, we pass this graph in only 1 point. So that means this is a function, but inverse is not a function. So this is not one-to-one function. So one-to-one we have part B and C. Graphing inverse function. If the point A, B is on a function, then interchange this order pair. So we have B, A is on the inverse. So they mirror each other through the line y equal to x. So here we have this graph, and we have this point A, B. Using what we have here, that is y equal to x. So drawing this line perpendicular to y equal to x and crossing this point A, B, we can find on the other side B, A. So we can mirror all these points. So all the points that we have on this graph to the other side of y equal to x. This means we mirrored our graph using y equal to x. So we're gonna do the same thing here in our example. The graph of the function f is here. Based on what is given, we will use that graph to draw a graph of its inverse function. So here on this part, we have ordered pairs given. We have y equal to f of x. So what we have for f of x, ordered pairs are -3, -2. Then we have -1, 0. We have 4, 2. And then based on that, what we have for inverse, we have to interchange x and y. So we have -2, -3, 0, -1, 2, 4. So finding these points, we have 2, 4, we have 0, -1, and we have -2, -3, and then connect these 3 points. This one is inverse, and the one that I have in orange color, that is y equal to x. So we can use y equal to x and then mirror our graph, or interchange x and y. Now here, number 2, we have this graph is given. So based on this, what we have for f of x, we have these 3 points, and those are 0, 1, -1, 2, -2, 4. So f inverse is 1, 0, 2, -1, and 4, -2. So finding these 3 points and then connect all these to have f inverse. So this means what we did, we mirrored all these 3 points using y equal to x. And here in this example, given f of x equal to 1/3 times x minus 1, find the following. Part A, find f inverse. Part B, graph f of x and f inverse. So y equal to 1/3 times x minus 1, interchange x and y. So x is equal to 1/3 times y minus 1. Now solve for y, so LCD is equal to 3. Multiply both sides by 3, so we have 3 times x equal to 3 times 1/3, that is 1 times y is y, 3 times -1 is -3. Then solving for y, so here add 3 to both sides, we have 3x plus 3 equal to y. And then instead of y, use f inverse. So this is equal to 3x plus 3. Now graph. So here, based on our function f of x, which is equal to 1/3 times x minus 1, for x I used 0, 3, 6. So here, using 0, we have 1/3 times 0 minus 1, our y is -1. X equal to 3, so we have 1/3 times 3, that is 1 minus 1. So here we have 0. Using 6 instead of x, we have 6 divided by 3, so that is 2. 2 minus 1 is 1. So we have these 3 points. Find these 3 and then connect to draw this line for f of x. And then for inverse function, we have to interchange x and y. So we have -1, 0, we have 0, 3, and we have 1, 6. Find all these 3 points and connect these points, that is inverse function. So that is inverse for what is given here on the spot. So this means we mirrored these points using y equal to x. So we graph both f of x and f inverse.